All right, so at this point, we've talked about how to write the electron configuration, the long way, the short way, and so now we're going to talk about, and it's always been for a neutral atom. Now we're going to talk about what if it's not a neutral, what if it's an ion? So we're going to talk about anions and cations. So to write the electron configuration for an anion, the first thing we want to do is to write the electron configuration for the neutral atom. So first write it for the neutral atom, and then add the appropriate number of additional electrons, and we're going to do this in the normal order. Okay, so remember, anions have extra electrons. So we write the neutral and then we just add the extra electrons in the normal order. So on the rest of this slide, you can write what I'm about to write on the periodic table just so you can see it. Okay? So the first one we want to do is I want to know what is the electron configuration for S2 minus. So I say, what's the electron configuration for S2 minus? So to do S2 minus, the first thing I want you to do is to do S. And we can do the shorthand. Unless I specifically ask for the long one, you could always do the short. So let's find sulfur. Sulfur is over here, it's number 16. So we want to pick the closest, but not over noble gas. So we go up and over, and it's neon. So we have neon. Neon's number 10, so we come back over here with a number 11. We're in row 3, we're in the S block, so it's just the N number, the row number. So 3S, 1 and 2. And then now we're over here, we're in the P block, so it's still the row number. So it's 3P, 1, 2, 3, and 4. So that would be for the neutral. So neon 3S2, 3P4. But I want S2 minus. So S2 minus means it has 2 extra electrons. Right now, this guy, he's got 10, 11, 12, 13, 14, 15, 16. Okay, so we need to add 2 more. So we add to wherever we stopped. So the P orbitals, 3P, this could have up to 6. Okay, so remember, P could have up to 6. So I need to add 2 more. So that means I can put those 2 in here because he only has 4 and he can have up to 6. So I write out the same thing, and then here I put 2 more to give the 6. Another way you can think about it is you're here, I need to go over, so it'd be 3P, 1, 2, 3, 4, 5, 6. Now, this is also, S2 minus is also equal to something else. This is a correct answer, but there's another correct answer. Ooh, yeah, put minus, sorry. So if I'm here and I need to add 2 electrons, I go 1, 2, and it's actually equal to argon. So you could write it either way. You could write it this way, or you could write it this way. Both would be correct. All right, let's do another example. So this time I ask you, what is N3 minus? So if I ask you N3 minus, you have to write the neutral first. So we find nitrogen. Its noble gas is going to be helium. And then we're here, 2S2. And then we're here, 2P, 1, 2, and 3. Okay, so 2S2, 2P3. So now, because we have 3, we need to add 3. We said, okay, the P orbital can have up to 6. He only has 3, so he can take all 3. So that means I can put all 3 in this P orbital and fill it up. So helium, 2S2, 2P6. So you think about it, you were 2P, 1, 2, 3, and then you add 3 more. 4, 5, and 6. But just like before, this guy is also equal to something. And so he would be equal to, if I was here and I went 1, 2, 3, he would be equal to neon. So either of these two answers would work for the anion. All right, so let's switch gears and let's do the cations. So same thing, we want to write the electron configuration for the neutral atom and then remove the appropriate number of electrons from the highest energy levels and sub-levels first. Okay? So it's kind of like going backwards. So now we're going to remove, but we want to remove those valence electrons. We want to remove those outside electrons because those are the easiest ones to kind of grab and take off. All right, so let's do some examples. Let's go back to my periodic table so I can see it. All right, so this time I want you to write the electron configuration for Fe2+. So Fe2+. So if I ask you for a cation, if I ask you for any ion, you always write the neutral. So let's write the neutral, Fe. So let's find Fe. We're right here, number 26. So the noble gas would be Ar. So we write Ar. And then we're over here, we're in the S block, so it's the row number, so 4s, 1 and 2. And then we're in the D block. So the D block is the row -1, so this isn't 4D, this is 3D. So 3D, 1, 2, 3, 4, 5, 6. 3D, 6. Now, you might be thinking, oh, well, I stopped with a D block element, so do I have to worry about the exception? We don't worry about the exception if we're making an ion, okay? So if we're dealing with exceptions and all of that, don't worry about it unless it's just a neutral element that we're dealing with. All right, so it says that we want Fe2+. So if it's a 2+, that means he lost 2 electrons. So I have to take away 2 electrons. But I don't take away from just the last thing I wrote. You have to take away from the highest orbital, the highest energy level. So remember, the highest energy level is based on the N. So this has an N equals 4 and this has an N equals 3. So the N equals 4 is higher. It's going to be on the outside. So this is where I'm going to take my electrons from. How many do I need to take? I need to take 2. There's 2 here, so I take all of that. So all I do is I write Ar, I leave this out, and I write 3d6 because I took out those 2 electrons. So if you look, Ar was 18, 19, 20, 26. And now here I'm at 18 plus 6 is 24. Okay? So you don't just go backwards and say, oh, it's 3d4. You have to take from the highest orbital. Now, what if I wanted to do Fe3+? So if I asked you Fe3+, it's the same thing. You need to write the neutral. So I write the neutral, and then I say I need to take from the highest orbital. So the highest orbital is my 4. So I know I'm going to take away these guys. But how many was there? It was only 2 there. And I need 3. So I have to take away from the next highest. The next highest is my 3 here. So I'm going to take 1 away from there because I took 2 here and then 1 here. So this would be Ar 3d5. All right, so, and then if you're thinking about rearrangements, if you're like, why doesn't it rearrange? Well, he's half full, and he doesn't have anybody higher to rearrange from. So that's why we don't have to worry about rearrangements. If you're doing an ion, you just leave it be. All right, let's do one more. So let's say I wanted Ga+. So if I want Ga+, I gotta do Ga. So let me find Ga, here's Ga. And so I need my noble gas, so I go up and over. So I got argon, so I write Ar. Okay. Then over here, I'm in my S block, so it's the N, 4s1 and 2. Now I'm here, I'm in my D block, so it's N minus 1. So that's 3D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3, ooh. Said 3 and I wrote D. 3D10. And now I am over here. I'm in my P block, so it's the row, so it's 4P, just 1. And you can check, remember 18 is argon, 18 and 2 is 20, 31. All right, so now I want just plus 1. So I need to take away 1 electron. All right, so my choices here is something that's in the outer block. So I have the highest is my 4s and my 4p. These are the highest. So then I have to say, well, which one am I going to take away from? This guy is full. This guy is partially full. Okay, so think about the trends that we've already talked about. This guy is going to be easier to take away from. When you're not sure if they're the same energy level, then you can do the one that you did last. Is an easy way to remember it. So we're going to take this 1 electron, because I only need 1, and take him away. So what's left would be my Ga+. So Ar, 4s2, 3d10. Now what if I wanted Ga3+? Same thing, write out your Ga, and now I need 3 electrons. So I need them from the highest. So this is a 4, and this is a 4. There's 2 here, there's 1 here. So I only have 3 electrons that are in the highest outside energy level. So I'm going to take all 3. I'm going to take this guy and this guy. So I'm end up taking away from here and from here. So I'd have Ar 3d10. Okay? And you can always check. Remember, if Ga has 31 electrons, then if I take 3 away, then I should only have 28. Argon is 18 and 10 is 28. So you can always check it. All right, so that's how you write your electron configurations for an anion and for a cation. So now we want to talk about one more term and then we'll be done.